All right, let's bounce back over to the homework, and we will look at number 75. It is a central nervous system stimulant, and is used in nasal sprays and decongestants. It's a compound that is a weak organic base. So we have this formula sitting here. It's reacting with water. We have a concentration. It has a pH value. What are the equilibrium concentrations of blah, 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 everything in here. So I'm kind of just making the assumption it's going to be a rice table problem. But this is, well, let's go ahead and just set this up really quick. And again, I'm kind of lazy about this. I don't typically write the whole formula out. I just write down like HA if it is an HA kind of thing. Or if in this case it's telling me it is a weak base. So it's a slightly different approach to this type of problem. If it's an acid, you can simply just write HA because the acid will just separate and form H and A. But if it's the other way around, a base instead of an acid, we have to have some water present. And again, everything here is aqueous, so that's perfectly legitimate, okay to do. You have to have water present because where is it getting the hydrogen from? So they already set it up the real problem here. If I do it the generic way, or they don't tell me, I'm going to write out A plus H2O producing the acid form of it. So I'm going to say HA plus OH minus. And I'm going to put a little plus here too because it did accept a hydrogen on there. Okay. Taking a look at the rest of it on here as far as the concentration goes, we have the original concentration. Water I can just ignore because it's a constant. I don't have any of this present. And then if I take a look at everything else it's asking me to do, the pH. So it gave me the pH. So that's interesting. What I can actually do with that is go in and figure out how the pH would translate over to a concentration. So I can say 10 raised to the negative 11.33. And what that'll give me is the pH, the hydrogen ion concentration. Once I have the hydrogen ion concentration, I'm going to take that one step further and subtract it from 1 times 10 to the negative 14. If I subtract off that value, that's going to give me the OH concentration. I want the OH concentration to solve this problem. So again, I have a pH. I can take pH and turn it into hydrogen ion concentration. Having hydrogen ion concentration, I can subtract that from the Kw value, which is right here. That's a constant. And that gives me the OH concentration. Doing all of that gives me 2.14 times 10 to the negative 3, and 2.14 times 10 to the negative 3. And of course, those were added values. I'm not going to write those in, putting those here. And it is a subtracted value. I will write that one in over here. And if I actually do the math here, I'm not going to be lazy. It'll give me 0.033 for an answer. Now I can go in and figure out what the Kb value is. And somewhere in here it does ask for that. What are the human concentrations of these guys here? I have them all. I don't know if it asks for that or not. Let me take a look on the next page. I would assume I needed that. It does. Calculate the Kb. So that's left off my particular page. I'm going to go ahead and solve for that. And it is 2.14 times 10 to the negative 3. There's two of them, so squared over the original concentration, 0.033, is equal to 1.39 times 10 to the negative 4. And that's the whole problem right there. Right, let's bounce back over to the notes. All right, this is kind of a fun problem. There's lots of little parts to this one. We are dealing with some solid sodium hypochlorite, which is also better known as bleach. So we have some of this sodium hypochlorite, and it is added to 2 liters of water. So it is a solid. We added some amount to water to make a solution with a pH equal to 10.5. So we've seen a couple examples. We can probably assume how it's going to fit into this problem. The question is, or part of the question anyways, is how many moles of sodium hypochlorite must be added to make this true. I'm not going to write that part in. All right, so I can take a look in the book, in the back of the book, and I won't find sodium hypochlorite in the back of the book because that's the salt. What I will find is hypochloric acid. If I look that up in the book, I will find a Ka value equal to 3.0 times 10 to the negative 8. And because I have this value, based on what we were talking about before, is Kw is equal to Ka times Kb. So again, this is the true acid that I will find in the book. Here's its answer, or its value. I can therefore find the Kb that goes along with it, the sodium hypochlorite. That's the Kb. So if I divide 1.0 times 10 to the negative 14 by the Ka, I'll get the Kb value, which just so happens to be 3.3 times 10 to the negative 7. All right, so let's set up a problem just like we were doing before. I'm going to mix mash things a little bit here compared to how we did in the previous problem. I'm going to say you've got some water. And we have the sodium I'm just going to ignore because it doesn't do anything. The hypochlorite ion. And when these guys are in solution together, of course, it's going to take just a little bit hydrogens with it and form the weak acid. And then, of course, it's going to have a little bit of hydroxide left over. And now we can kind of see how some things are going to fill into the problem because I have pH. I will put the lines here. I don't need to worry about that. I'm actually trying to figure this out here. How many moles of this original stuff do I need? Initially, I don't have any of these, but I know what the pH is somewhere. The pH is 10.5. If I do all the little parts here, if the pH is that, I'm going to do it a little bit differently. Don't forget that pH plus pOH is equal to 14. So if this is 10.5, the pOH is 3.5. And if I know 3.5 for the hydroxide ion concentration, I can say 10 raised to the negative 3.5 is equal to 3.2 times 10 to the negative 4. Having that value, I can put that in down here for both of these because they ionize equally. 3.2 3.2, and of course that was an additive value. Over here it is subtracted, which looks a little bit interesting. All right, now how is this supposed to work? Let's put it together and see if we can find out. Now let's remember that if we're doing a Kb, it works just the same, products over reactants. HClO, OH concentration, over no water, ClO minus. If I put in the values, 3.2 times 10 to negative 4 squared over x minus 3.2 times 10 to negative 4, and it is equal to 3.3 times 10 to negative 7. If we do all the algebra here, work this out, you will find that x is equal to 0.31 molarity. And so I figure, okay, well, what am I supposed to do with that? Well, that is, again, the molarity of the hypochlorite. But that's not what the question asked for. How many moles? So don't forget that molarity stands for moles per liter. Well, I have 2 liters. So if we multiply this times 2 liters, we will get 0.62 moles. There you go. That's the answer, and that is the end of this lecture.